Hello, my dear students. I welcome you back to the session on Big Data Analytics. In today's session, I'm going to discuss about the Big Data Analytics. I'm also going to discuss about the Hadoop ecosystem, and I'll also be discussing about a Hadoop cluster. So let's begin today's session. So Big Data Analytics is the process of examining large amounts of data of a variety of types to uncover hidden patterns, unknown correlations, and other useful information. For this, there are many big data analytics solutions available in the market. I'll just give you a preview of each one of them. Number one is the Tableau, is a visualization tool. Then we have SAS, which is for statistical computing. Then IBM and Oracle also provide a range of tools for big data analytics. Then Revolution is also used for statistical computing. R is one such language which is used for statistical computing. We discussed in our previous lectures about the 5 V's of data, okay? But primarily, while we are discussing the analytics, we focus on the volume, velocity, and the variety. Obviously, veracity and value come after you analyze the data and you pick up the correct part out of it, the value part from it, and the true part from it. But we must see the volume of the data is huge, the velocity at which it is being generated is very fast, and there is a variety of data that is there. So obviously, a question would come to mind that why to put big data and analytics together now? We have got huge, huge amounts of data with us, with the big data. Why should we analyze it? Simply because big data provides gigantic statistical samples which should be analyzed for corporate and enterprise growth. And we have got analytical tools and databases which can now handle big data. And analytics based on large data samples are always going to reveal and leverage business change, because it would suggest what should be done to improve the business, what should be done to attract the customers, what should be done to enhance the revenue, and so on. And there is always a lot to learn from messy data as long as it's big. So obviously huge amounts of data would provide us great insights and would help us to come up with good solutions for industry and enterprise. So prior to big data analytics, the traditional analytics, or the business analytics as it is called, let's see the differences between them. The difference between the business analytics that we have been doing, or the business intelligence that we call it, versus the big data analytics. Okay, so the traditional analytics, the business intelligence type, is for descriptive analytics, for diagnostic analytics, whereas big data analytics is for predictive analytics, for data scientists to explore patterns, correlations from data. And as so far as the data sets are there, we have got limited data sets in our traditional model, and we need to clean the data, and there are simple models to analyze the data. Whereas in big data analytics, we are concerned with large scale data sets, more types of data, raw data, unstructured data, and complex data models are there because the data is unstructured. And obviously, the thought process in traditional analytics is like what happened and why. Whereas in big data analytics, we are more concerned about the correlation that the data presents, and we are looking for new insights to get more accurate answers. Now we can shift to our yesterday's presentation. Okay, so I discussed with you something known as a Hadoop ecosystem. So a Hadoop ecosystem is comprised of all these components. You can have a look how this is arranged. At the bottom of the Hadoop ecosystem is the Hadoop distributed file system. That is the storage for the big data files. So it is, in short, it is known as HDFS. Okay, and then on top of HDFS is the MapReduce algorithm, the analytics algorithm that we discussed. Now we have got many improvements on that MapReduce version, MapReduce analytics algorithm. We have got Uzi, we have got Pig, we have got Mahout, we have got R connectors, we have got Hive, Then there are components like plume and scoop, which we'll discuss one by one when we discuss the Hadoop ecosystem. But this slide should give you an idea that the most important components to begin with are the first two, that is the HDFS and the MapReduce, or which is now has a new nomenclature in terms of YARN, YARN, which stands for yet another resource negotiator. So YARN can also be, called as MapReduce version 2. These two things are there, and the rest are all the abstractions and the configuration managements and the schedule managements for a given cluster. Okay, so I'll be coming up an explanation for all of these components in this video itself. But before that, let us first discuss what is a Hadoop or a Hadoop distributed file system cluster. Okay, so a cluster is usually it consists of a heavy duty machine known as the admin node, and further it may contain 50 to 20 commodity machines known as data nodes. So we are taking a small example. Otherwise, Yahoo has clusters with excess of 50,000 data nodes. Okay, so obviously when you have got huge amounts of data to store and analyze, then bigger is the cluster size. Okay, but let's discuss a small cluster in which always there is a heavy duty machine known as the admin node, and furthermore there could be 15 to 20 to 30, 40 commodity machines known as data nodes. Okay, so two types of machines we are discussing here. One as the admin node, which is a heavy duty machine, and one the commodity machines which are like slaves to this admin node. So we can have a master slave architecture where admin node is the master and commodity machines, they follow the admin node. Okay, let's discuss their configuration one by one. So admin node is usually a Xeon processor with at least a 64 GB RAM. So it's a big server with a Xeon processor and at least 64 GB RAM. Whereas commodity machines are usually i7 processor with 1 TB hard disk and minimum 8 GB RAM. We may have 2 TB hard disk also, but usually the commodity machines have a 1 TB hard disk with them. Now there are separate different processes or daemons running on these machines. So two daemons are running on the admin node, which are known as the name node and the job tracker, and two daemons are running on the commodity machines. Number one is the data node, number two is the task tracker. So obviously you can understand that data node always follows the name node and task tracker always follows the job tracker. In Hadoop, this MapReduce version 2, that is the YARN, we have got different names for job tracker and task tracker, which I will discuss at an appropriate moment with you guys. Okay, let's see what these processes do. Now the name node, it stores, manages and helps in accessing big data files. Okay, so name node is not actually storing files. It is simply managing the data about this data. That is, name node is storing metadata. Metadata is simply data about data. That is information about data. So name node stores simply the metadata, whereas the actual data is stored on the data node. Okay. And similarly, for analyzing the data, the job tracker manages the MapReduce algorithm implementation, and task tracker executes MapReduce algorithm by interacting with job tracker. So task tracker is running on a slave machine, on a commodity machine, and it is always in touch with the task tracker, job tracker. Okay, and so a task tracker is always following the job tracker. Is that clear? Can you visualize a cluster now? One heavy duty machine known as the admin node, 15, 20, 30, 40, 100, 200 commodity machines, okay, which are lesser in configuration, but still the configuration is good. You can see it's an i7 processor with 1 TB hard disk and 8 GB RAM. These are called commodity machines because they are prone to failure. They are prone to failure. And that is why they are in large numbers, that if one of the machine goes out of order, then some other machine can take its place. Two daemons are running on the admin node. name node and job tracker. Job tracker is an older name. Okay. Uh, the new name I'll come up with in my next video because it's not relevant here to discuss the new names. And similarly, commodity machines have got two processes running on it, data node and task tracker. Data node is in sync with name node, and task tracker always is following the job tracker. Job tracker is assigning the jobs to be, which needs to analyze data, and task tracker is actually monitoring the analysis of data and sending report to job tracker. And name node is not storing actual data, it is simply storing metadata, that is data about data. And data node is storing the actual data. Okay. And job tracker manages the analysis part, and task tracker actually executes the analysis by interacting with the job tracker. Okay. So this is regarding the HDFS cluster. Let me now go to the ecosystem slide so that we can see actually what are the ecosystem components of Hadoop in detail. Okay. So this Apache Hadoop is a framework for running applications on large cluster. Now you are clear with the term cluster. With a large cluster built of commodity hardware. Okay. So a large cluster in which there are thousands of commodity machines, and a reliable shared storage and analysis system, a framework for MapReduce, and this Hadoop is a top level Apache project. Remember, all the analytics that Hadoop does in the background is dependent on MapReduce. We may have other processes running in the foreground, but MapReduce is the backbone of the analysis in Hadoop. Okay. So we can say it's a flexible and available architecture for large scale computation and data processing on a network of commodity hardware. Okay, fine. So this diagram you saw before some time. Okay, now let's see what are all the Apache Hadoop ecosystem components. We have got the Hadoop distributed file system. We have got Hive, Pig, Yarn, Flume, Scoop, Oozie, Zookeeper, Mahout, Ambari, and HBase. So you can see all the components here. So let me just discuss these components one by one. HDFS, as you see, stands for Hadoop Distributed File System and is used for managing big data sets with high volume, velocity, and variety. And the features of HDFS are that it's scalable, reliable, and runs on commodity hardware, and is used for data storage. Hive is a high-level query language. Okay. Just like your SQL, the structured query language, in Hadoop we have got the Hive language, that is the HQL, Hive query language. Okay, and it is used for query analysis. Okay, now it is an abstraction over MapReduce. When you run a Hive query, actually in the background you are running the MapReduce query. So MapReduce is managing all these front languages, Hive, Pig for analysis, but it hides all the complexity from the user. Similarly, Pig is a high-level language built on top of MapReduce for analyzing large data sets with simple ad hoc data analysis programs. So in all my future videos, I intend to begin with the HDFS discussion with you guys in detail. I'll be discussing the HDFS. I'll be showing you an actual cluster. Then we can discuss Pig and Hive also. But we'll begin our discussions with the HDFS, that is Hadoop Distributed File System. A quick recap for other things. Yarn is the yet another resource negotiator. It's also known as the MapReduce version 2. And the two major functionality of job tracker in MR, that is MapReduce volume 1, resource management and job scheduling, are split into separate daemons. So the new names for the processes are resource manager and node manager. Okay, so your job tracker is your resource manager and your task tracker is your node manager. Okay, and then there is a Flume language, okay, which is used for moving large amounts of log data. The Scoop is there if you need to move data between relational databases and Hadoop. Then Oozie is a workflow scheduler which helps you to schedule your jobs. And then Zookeeper is there for configuration management. An important part is the Mahout, which is a machine learning library for you to predict outcome on the analysis of big data. So Mahout is an important component. Similarly, we have Ambari is designed to make Hadoop management simpler, and HBase is an open source non-relational distributed database model after Google's Big Table. So that's all for today, guys. Keep watching. Thank you very much.